I'm Keith McKay with ScaleFlux. Today we're going to walk through some basic installation and configuration tips for the ScaleFlux CSD 3000 series NVMe SSDs. The first thing we'll assume is that you've physically connected the disk to the server and that you're operating in a Linux environment. The first thing after physically installing the drive is I like to make sure that it shows up on the PCIe bus. And one of the easiest things that we can do is use LSPCI with our vendor code, which happens to be CC53. And that will just show any ScaleFlux devices connected on PCI. If you don't see a listing for the devices that you expect to see, then there are a couple explanations. One is that you may need to reseat the drive. It may be connected behind a RAID controller. RAID controller will often, hardware RAID controllers will prevent the drive from being able to be seen on a PCI bus because it sits on the other side of a RAID controller. So if it shows up in LSPCI, it means it's on the PCI bus, can be seen by Linux, and we can move on. The first thing I like to check is a little bit additional information. So we use the -V's option in LSPCI to just get a little bit more information about the nature of the connection. And what I'm really looking for is link status. So if I just look for grabbing out the link status field, I want to see that we're linked at Gen 4 by 4. And so that's indicated by the 16 gigatoggles per second, which means Gen 4, and our link width is by 4, which it's reporting here. So we know we're good to go. If we saw something that was 8 gigatoggles or it's marked as degraded, then we know that the link quality, something is amiss there. And one thing we can do if that happens, we can just try reseating the drive and then looking at it again. Another one that I look for, and this is usually we're going to be bound to the NVMe driver. In some setups, if there's been, for example, some sort of other software that takes control over NVMe devices, it might not show up, but we want to make sure we're using the inbox NVMe driver. The rest of this, the content here is predicated on using the inbox driver. If you happen to not have LSPCI installed or can't install the package, which is PCI utils, the same information is in sysfs. However, it does require a little bit of hunting around for the right bus device function number. Once you can find that, you can find the vendor ID under the vendor file there. Just look for CC53, which is our vendor ID. And then we can also check the current link speed. We can check the link width and the model name. So similar information, similar thing we're trying to do here, just establish that the drive is connected on PCI at the full link width and speed, and that it's bound to the NVMe driver. Now, the other thing we'll want to do is install NVMe CLI. Typically, that's coming with the distribution. If you don't have it, you can install it with your package manager, or you can download the very latest from GitHub and build it yourself there. The advantage of doing it from GitHub is that you can get all the latest versions of the different vendor plugins and be at the very top of the version there. If you install from a distribution, you might be a little bit behind the tip on GitHub, but either way is fine. We're not going to use any vendor unique commands here, so installing from the distribution should be okay. So we do an NVMe list, and we see a ScaleFlux drive connected. This is a 384 terabyte physical drive, and currently it's formatted to 512 byte sector size. So we're all is well. We're happy to see this. And the other thing we'll want to do, and this is optional, but we'd recommend it, is installing the SFX tools package. And you want to go to packagecloud.io/ScaleFlux/CSD3K. And it'll give you instructions on how to install a repository. From there, you can find SFX tools. And one of the things that SFX tools will provide is a script called SFX status. And really, this is nothing more than a bash script that looks at a couple different NVMe logs and aggregates that information here, and just makes it easy to see all the pertinent information for this device in one place. Again, since it's a bash script, you can go ahead and look at it and see where it's collecting all this information, or use it as a reference for building, or modifying the script to suit your own needs. Once we have this basic step here, we know the drive's healthy, we know it's connected. We can change the sector size. And I always like to change the sector size from 512 to 4K. It's not strictly necessary. The drive ship is 512 by default for the maximum compatibility, but 4K gets around any kind of alignment issues that may happen, and they're quite rare these days. But I tend to prefer 4K personally. That is up to the your requirements. So after we finish formatting, we look at another log that's really important. This is identify namespace. So identify namespace has three really key capacity parameters. It has something called namespace size, the namespace capacity, and the namespace usage, as end size, end cap, and end use. This drive supports thin provisioning. So the big feature for the 3000 series is transparent compression. And one of the things that you can do with transparent compression is extend the size of a namespace. And you can make that namespace bigger than the namespace capacity. And that is allowed through the NVMe thin provisioning feature set. And so once you do that, you may have an end size bigger than end cap. And what you want to do in this case is make sure your end use stays below your end cap. And so this identify namespace log is where we're going to get that information for monitoring to make sure that the drive doesn't physically overflow. The next thing that we're going to look at is creating a bigger namespace. So this is a 3.84 terabyte drive. We're going to go ahead and we're going to delete the namespace that exists, and we're going to create a new one, but the new one's going to be 768 terabyte. So remember, this is still a 384 terabyte drive, but we're making a namespace size that is double that. So the assumption is that we're going to be using, storing compressible data on the drive, and that will need to be in aggregate about 2-to-1 compressible to fill the drive, to prevent the drive from overfilling its physical capacity. So we go ahead and detach namespace. We're going to delete it. After we delete the namespace, we're going to create a new namespace with an end size double of end cap. And then we are going to go ahead and attach that namespace. And we're going to rescan. And then we're going to look at the new drive. So now, recall before we were at 512 byte, 3.84 terabyte. Here we've jumped to 768 terabyte on the same drive, and of course formatted to 4K sector size as previously. And so that's as simple as it is to create a new namespace that's thin provisioned, and just a few easy steps there, and using all the normal NVMe commands. There's no vendor unique commands required to do that. And it's all made possible through the thin provisioning framework. So hopefully some of these tips are helpful and get you started using ScaleFlux more quickly.